The first chapter we're starting with in functions is chapter P, Prerequisites. In this chapter, we'll touch on some of the concepts that were on your review worksheet on the first day of class. We're going to start with P2, exponents. In this lesson, we'll look at simplifying expressions using properties of exponents and model scientific notation. There are 8 fairly common properties of exponents. You're going to want to know all 8 of these. The most common ones are first, if you have the same base with different exponents and you're multiplying the bases, notice you add the exponents to combine them. So when you multiply bases, you add exponents. Property 2, when you divide bases, you subtract. So the opposite operation. When you have a negative exponent, you take the reciprocal of the base and that drops it down to the denominator. Property 4 is pretty easy. Anything to the 0 power is 1, whether it's a variable or a number. 5 is known as the distributive property. If you have 2 bases to the same exponent, you can distribute the exponent in, and then each base gets that exponent. If you have a base with an exponent on the inside, and then it's raised to the one on the outside, to get the output exponent, you multiply. So there's all these kind of little different situations based on the type of property you're looking at. 7 is kind of like 5. Although in 5 you are multiplying the bases, for 7 you're dividing. But you can still distribute that exponent in to the top and the bottom. Now the last property has an absolute value. We don't use this one as much, but if you're squaring an absolute value, it's simply the same as that number squared. Get to know these 8 properties. Let's put some of those properties to the test. Evaluate each expression. Use only positive exponents when necessary. What that means is we won't have any negative exponents in our final answer. Now for the first example, -5 is in parentheses and it's being squared. So what that means is we're taking -5 times -5. And anytime you multiply 2 negatives, you get a positive. They just cancel out. And 5 times 5 is 25. Seems straightforward enough. That shouldn't have been too difficult. The difference, however, between the first example and the second one is the fact that the negative isn't in the parentheses being squared. So technically, this second example means it's -1 times 5 squared. In order of operations, you would actually square the 5 first and then multiply it by -1, and you get -25. So negative signs are going to have a significant impact in how we simplify. Other properties, we have 2 times 2 to the 4th power. This first 2 doesn't have an exponent written, so we would default it to an exponent of 1. Times 2 to the 4th power. Now, when the bases are the same, we just add the exponents together. 1 plus 4 is 5. That's the same as 2 to the 5th, or if you plug that in, you get 32. The next one, 4 to the 4th power divided by 4 to the 6th power. Kind of like this one we just did, when the bases are the same but you're dividing, you're going to subtract the exponents. So this would become 4 to the 4 minus 6 power. You should always do the numerator minus the denominator. But when we do 4 minus 6, we get -2 as our exponent. So then we have to apply the negative exponent rule. To make that positive, we take the reciprocal of 4, which is 1 over 4. And that makes -2 become +2. Take that just one step further, 4 squared is 16. All right, let's try some ones on the bottom. Now these might have a combination of some of the properties. -3 ab to the 4th times 4 ab to the -3. Notice everything's in parentheses, so I'm going to match up my bases. Taking a look first at just the coefficients, I have -3 and +4. When I multiply them, I get -12, and that's my coefficient out in front. Now I'm going to look at the A's. I have just an A here and an A here. A times A becomes A squared. Finally, the B's, we have B to the fourth times B to the negative 3. That means we're going to add our exponents, and 4 plus negative 3, which is 4 minus 3, is just 1. And that's it. There are no negative exponents. You can have a negative coefficient, but no negative exponents. All right, you guys, let's keep moving on here. 3a times negative 4a squared to the power of 0. Whoa, there's a lot happening here. Taking a look and thinking about order of operations. If we look at the parentheses first, notice negative 4a squared is being raised to the 0 power. Well, this is kind of a freebie. Anything to the 0 power, no matter what it is, defaults to equal 1. So that means we have 3a times 1. And anything times 1 is just itself. Our answer just simplifies to 3a. That was pretty easy. Our next example, x divided by 10, which is a fraction, to the negative 1 exponent. If I want to make negative 1 positive, we're going to take the reciprocal of the base. So x over 10, if we flip it to its reciprocal, becomes 10 over x. And what that does is makes negative 1 become positive 1. And that just equals 10 over x. Simplified. So again, pretty quick. Last but not least, we have a fraction with negative exponents, we have coefficients, we have matching bases, lots going on here. We have 3a to the negative 3b to the fourth divided by 15ab to the negative 1. Like our example on the first part of this row, I'm going to just take part by part, starting with the coefficients. If we have 3 on top and 15 on bottom, that's going to reduce to 1 over 5. 3 goes into 15 5 times. Taking a look at the a's, we have a to the negative 3 and a to the 1. If we subtract exponents, negative 3 minus 1 is going to be a to the negative 4. Well, 4. There we go. Oh, let me fix that, you guys. Sorry. Sometimes my stylus pen doesn't like to cooperate. There we go. A to the negative 4. And lastly, we have b to the fourth over b to the negative 1. Now be careful here. When you subtract the exponents, we get 4 minus negative 1, which would be a double negative. And that would make it 4 plus 1, which is b to the fifth. So as is, we have a to the negative fourth, b to the fifth over 5. The problem with this one is we have a negative exponent. To make that negative exponent positive, we need to put a down in the denominator with the 5. So that means in the numerator, we're going to have our 1. We'll have b to the fifth, and then all over 5, and we'll drop that a down to the denominator and give it a positive exponent of 4. Let that sink in, and then we'll talk about some scientific notation. We'll end our video lesson with a little bit of scientific notation. This ties into section P2 because scientific notation uses exponents as a way to simplify large or small numbers. Take a look at this first number, 366, and then it has a whole bunch of zeros after it. If you had to write that out every time to simplify an expression or solve a problem, that would take a lot of time. To use scientific notation, the bigger the number, the bigger the exponent is. So if we count up the groups of zeros, we've got 3, 6, 9, 12, 15, 18. Go till you get to one number in front of the decimal, 19 and 20. So this would be 3.66 times 10 to the 20th power, which means there are 10 decimal places after the initial decimal written. So again, the bigger the exponent, the bigger the number. Versus the next example, if it's already in scientific notation, 9.1 times 10 to the negative 8. If you have a negative exponent, that means your number is small. We're going to move 8 places to the left. So move 8 places to the left. which means if you move it over once, you're going to have to put 7 zeros in front of that 9 and the 1. That doesn't even count the 0 that's in front of the decimal. So now you have to add 1, 2, 3, 4, 5, 6, 7, then 9, then 1. So again, a negative exponent gives you a very small numerical value. Our last example in the video, evaluate using scientific notation. 2,400,000,000 times 0.00000045 divided by 0.00003 times 1,500. Sounds like a pretty common problem you'd see in life, so let's simplify it using scientific notation. Now you could plug it all into your calculator. I totally get that that could happen. However, if you needed to utilize scientific notation in some other form or some other part of the problem, start by taking each parenthesis and converting it to scientific notation. That first problem, we've got 3, 6, 9 decimals. That would be equivalent then to 2.4 times 10 to the 9th. Put that in parentheses. The next one, if we're going to the left, or excuse me, to the right, 1, 2, 3, 4, 5, 6. Since that number is small, our exponent is negative. In the denominator, we have another small number, 1, 2, 3, 4, 5. So then that's 3, wow, never mind that. There we go, try that again. That's 3 times 10 to the negative 5th. And then that last one, 1, 2, 3, 1.5 times 10 to the 3rd. All right, let's take a look at what we have here. If we pull apart just the numbers, we would have 2.4 times 4.5. And then if we look at the rules for combining bases, bases that are the same, add their exponents together. That would be 10 to the 3rd. Divided by, once again, group the numbers together. It's all multiplication, that's why we can do that. 3 times 1.5, 10 to the negative 5th times 10 to the 3rd, negative 5 plus 3 is 10 to the negative 2. So notice the blues have matching bases, but the reds do not. Therefore, if we plug this into our calculator, 2.4 times 4.5, if you type that in, you would get 10.8. And the bottom, 3 times 1.5 is 4.5. And then if you do the 10 cubed divided by 10 to the negative 2, subtract your exponents, you would get 10 to the 5th. Now on your calculator, you could go one step further, 10.8 divided by 4.5, and you just get 2.4 times 10 to the 5th, which means if you move this, so you could have that answer, or if you move the decimal over 5 places to the right, you would have 240,000. And that's just a way of using scientific notation to simplify a fraction. That's it for this part of the notes. Once you have that done, there's no additional homework until tomorrow.